Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill in mathematics. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in mathematics. In this video tutorial, we will discuss two multiple choice questions with only one correct option on the rate of change of quantities by the method of differentiation. The questions are as follows. Question 1. Sand is pouring from a pipe at the rate of 12 cubic centimeters per second. The falling sand forms a cone on the horizontal ground in such a way that the height of the cone is always 1/6 of the radius of its base. Find the rate at which the height of the sand cone is increasing when its height is 4 centimeters. The options are pi by 48 centimeters per second, 1 by 48 pi centimeters per second, pi by 24 centimeters per second, and 1 by 24 pi centimeters per second. Question 2. A ladder of length 5 meters is leaning against a vertical wall. The bottom of the ladder is pulled along the horizontal floor away from the wall at the rate of 2 centimeters per second. Then find the rate at which the height of the ladder on the wall is decreasing when the foot of the ladder is 4 meters away from the wall. The options are 4 by 3 centimeters per second, 4 by 5 centimeters per second, 8 by 3 centimeters per second, and 8 by 5 centimeters per second. Before proceeding to solve the problem, let us recall the related concepts. Consider two variables x and y such that y is equal to fx. This means that y is a function of x and it changes whenever x changes. Therefore, rate of change of y with respect to x is given by dy by dx is equal to f dash x. When both x and y change with time, then we have rate of change of x with respect to time is equal to dx by dt, and rate of change of y with respect to time is equal to dy by dt. To establish a relation between the two, we proceed as follows. By the chain rule of differentiation, we have dy by dt is equal to dy by dx into dx by dt. Putting y is equal to fx, we get dy by dt is equal to d by dx of fx into dx by dt. Now, d by dx of fx is equal to f dash x, which gives dy by dt is equal to f dash x into dx by dt. Therefore, for a given value of x is equal to c, we have dy by dt at x is equal to c is equal to f dash c into dx by dt at x is equal to c. Now, we are in a position to solve the problem in the question using these concepts. First, let us solve the problem in question 1. Consider a sand cone as shown in the figure. Let us assume that the height of the cone AD is equal to h and the radius of its base BD is equal to r. It is given in the question that h is equal to r by 6, which implies r is equal to 6h. Now, sand is pouring at the rate of 12 cubic centimeters per second. Therefore, volume of the cone increases at that rate. Therefore, we write dV by dt is equal to 12 cm cubed per second. We are required to find the rate of change of height dH by dt when the height of the cone h is equal to 4 centimeters. Now, to solve the problem, let us establish a relation between the quantities involved in the question as follows. In the first step, we write the expression for the volume of a cone of height is equal to h and radius of base is equal to r. It is given by V is equal to 1 by 3 pi r square h. Now, r is not given in the question. Therefore, to solve the problem, we substitute r is equal to 6h, which gives V is equal to 12 pi h cube. In the second step, we differentiate this equation with respect to time using the chain rule of differentiation, which gives dV by dt is equal to dV by dH into dH by dt, which is equal to d by dH of 12 pi h cube into dH by dt. Now, d by dH of 12 pi h cube is equal to 36 pi h square, which gives dV by dt is equal to 36 pi h square into dH by dt. In the third step, we put dV by dt is equal to 12 cm cubed per second, which is constant. Therefore, we have 12 is equal to 36 pi h square into dH by dt, which implies dH by dt is equal to 1 by 3 pi h square. Therefore, when h is equal to 4 centimeters, we have dH by dt is equal to 1 by 48 pi centimeters per second. Therefore, the correct option is B, which is the answer to question 1. Now, let us solve the problem in question 2. Consider a ladder AB of length L leaning against a vertical wall as shown in the figure. Let the distance of the foot of the ladder from the wall is OB is equal to x and the height of the ladder on the wall is OA is equal to y. It is given in the question that L is equal to 5 meters and the bottom of the ladder B is moving towards right at the rate of 2 centimeters per second. Therefore, rate of change of x is dx by dt is equal to 2 centimeters per second. We observe that as B moves towards right, A moves downwards on the wall. Let the rate of change of y is equal to dy by dt. We are required to find dy by dt when x is equal to 4 meters. Now, to solve the problem, let us establish a relation between the quantities involved in the question as follows. In the first step, we establish a relation between x, y, and L. In the right angle triangle AOB, we have OA square plus OB square is equal to AB square, which gives x square plus y square is equal to L square. In the second step, we differentiate the equation with respect to time, which gives d by dt of x square plus d by dt of y square is equal to d by dt of L square. Now, d by dt of x square is equal to 2x into dx by dt. D by dt of y square is equal to 2y into dy by dt and d by dt of L square is equal to 0, since the length of the ladder is constant. On simplification, we get dy by dt is equal to minus x by y into dx by dt. In the third step, we find the value of y when x is equal to 4 meters, which gives y is equal to 3 meters. Now, putting the values of x, y and dx by dt and simplifying, we get dy by dt is equal to minus 8 by 3 centimeters per second, which implies that height of the ladder decreases at the rate of 8 by 3 centimeters per second. Therefore, the correct option is C, which is the answer to question 2. This completes the answer to the question.